This video is part of the course Forensic Physics: How Science Solves Crimes in Court, presented by the Physical Sciences Consultorium. Throughout this course, we have examined how physics constrains forensic evidence and how scientific reasoning supports legal decision-making without overstating certainty. In this episode, we focus directly on uncertainty and probability. These concepts often make courts uncomfortable, yet they are central to honest scientific reasoning. Understanding uncertainty is essential for interpreting forensic evidence responsibly. Courts often seek definitive answers. Science, however, rarely provides them. This difference creates tension between legal expectations and scientific practice. Physics does not eliminate uncertainty, it reveals it. A fundamental principle of physics is that no measurement is exact. Every measurement is an approximation of reality, limited by instruments, environmental conditions, and noise. This is not a failure of science, but an intrinsic feature of measurement. There is an important distinction between reality and observation. Reality exists independently, but observation is always filtered through instruments and methods. Forensic evidence belongs to the domain of observation, not reality itself. Uncertainty should not be confused with error. Error does not mean a mistake was made. It refers to the unavoidable variation that appears when measurements are repeated under similar conditions. Some uncertainty arises randomly, fluctuating from one measurement to another. Other uncertainty is systematic, arising from calibration, assumptions, or experimental design. Physics treats both explicitly. Repeated measurements rarely give identical results. This variability is not noise to be ignored, but information to be understood. Ranges convey meaning where single values mislead. Forensic physics therefore works with intervals rather than exact numbers. Whether estimating time of death, speed in an accident, or distance from a sound source, results are expressed as constrained ranges. Probability enters forensic reasoning as a way to express support, not truth. A probability does not state that something happened. It states how consistent a hypothesis is with the available evidence. This distinction is often misunderstood. Probability is not certainty, and it is not proof. It reflects the degree to which physics supports or contradicts a proposed scenario. Physics constrains probability by ruling out what is impossible. If a claim violates physical laws, its probability is effectively zero, regardless of testimony or belief. However, physics often leaves multiple possibilities open. When several scenarios are physically consistent with the evidence, science cannot choose between them. That choice belongs to the court. This limitation is not a weakness. It protects against overreach. Science that claims certainty beyond its data risks misleading justice. At this stage, it becomes clear why expert testimony matters. Experts translate physical uncertainty into language that courts can evaluate. Their role is explanatory, not persuasive. An expert witness does not decide guilt or innocence. The expert explains what physics allows and what it forbids, making assumptions explicit and uncertainty visible. In court, uncertainty must be communicated clearly. Scientific uncertainty is often misinterpreted as weakness, hesitation, or lack of confidence. In reality, it reflects methodological honesty and respect for evidence. Expert witnesses play a critical role in bridging this gap. Their responsibility is not to persuade but to explain. They must translate physical reasoning into language that judges and juries can understand without oversimplifying or exaggerating conclusions. One of the most common problems in court is false precision. Numerical values expressed with many decimal places can appear authoritative even when underlying uncertainty is large. Experts must actively resist presenting results in misleadingly exact terms. Probability is also frequently misunderstood. Courts may interpret probability as a statement of truth, when it is actually a statement of consistency between evidence and hypothesis. Physics uses probability to weigh support, not to declare facts. Another common error is confusing conditional statements. Saying that evidence is likely given a hypothesis is not the same as saying the hypothesis is likely given the evidence. This distinction is subtle but crucial in forensic reasoning. Experts must therefore be careful with language. Phrases such as consistent with or incompatible with are scientifically meaningful and deliberately restrained. They are not evasive, they are precise. Misuse of scientific models is another risk. Models simplify reality to make analysis possible, but they are never perfect representations. Applying a model outside its valid range can lead to incorrect conclusions. Forensic physics requires constant awareness of model limits. When environmental conditions, assumptions, or data quality deviate from ideal cases, conclusions must be adjusted accordingly. Courts may also encounter competing experts presenting different interpretations of the same evidence. This does not mean that science has failed. It reflects the fact that multiple models or assumptions may be physically plausible. In such cases, physics helps by identifying what is impossible. It narrows the field of debate even when it cannot select a single outcome. This narrowing is a valuable contribution to justice. Media portrayals of forensic science often distort this process. Television and film emphasize certainty, speed, and dramatic revelation. Real forensic science is slower, cautious, and transparent about limitations. When courts expect forensic science to deliver absolute answers, they risk encouraging overconfidence. Responsible experts resist this pressure and maintain scientific integrity. Uncertainty, when properly explained, strengthens evidence rather than weakening it. It prevents false conclusions and protects against misuse of scientific authority. This episode reinforces a central message of the course. Physics does not decide cases. It constrains claims. It defines what is physically possible and what is not. Expert testimony grounded in physics serves the court by clarifying boundaries, not by advocating outcomes. This restraint is essential for maintaining trust in forensic science. The Physical Sciences Consultorium is committed to promoting this responsible approach. PSC aims to foster scientific literacy where physics intersects with law, technology, and society. If you find this course valuable, please like, share, and subscribe to support continued open access science education. Your engagement helps sustain rigorous and ethical science communication. In the final episode, we will synthesize the entire course. We will examine the limits of forensic physics, reflect on what science can and cannot provide to the legal system, and draw together the principles explored throughout this series.